Today we're going to be talking about section 5.2, which is on medians and altitudes of triangles. So what is a median? A median of a triangle is a segment with endpoints being a vertex of the triangle, and it goes to the midpoint of the opposite side. So you'll see if I start at point C right here, and I go all the way across to the midpoint of AB, which is D, that's going to be my median. And so all of the medians meet at a point, and that point is called the centroid. Center, point, centroid. Now the centroid has something interesting about it. What it has is that the length of the median, let's say from B all the way over to L, the length from B to the centroid P is going to be 2/3 the length of the whole thing. 2/3. And that's true for all the centroids in here. So if you're looking at this right here, this is going to be the meat and bones of our centroid theorem 5.7. So if I look at this one right here, it says in triangle ABC, Q is the centroid and BE is 9. So Q right there is the centroid and BE, the whole thing, is 9 units. Find BQ and QE. So what we're going to do is we're going to look back at that theorem 5.7, the centroid theorem, and it says that BQ is going to be 2/3 the length of the whole thing, which would be BE. Now we know that BE is 9, so BQ is going to equal 2/3 times 9. Do that quickly on your calculator, you find that that's 6. Now there's a couple different ways then to find QE. The first thing you could do is you could say, okay, well if BQ is 2/3, then QE is going to be 1/3 of BE. Or you could say if I know the whole thing is 9 and BQ is 6 of it, then what's left over? That's going to be 3. Both of them work. Here's your guided practice problems. It's finding the length of FQ and finding the length of QC, which is right here. Example 2, use the centroid theorem again. So it says if we have triangle JKL, PT right here is 2 units in length. Find what QP is right here. Okay, again, we could do kind of the same thing we did before. Okay, so if we know the whole thing is going to be how many units if PT is 2. Otherwise, you saw in the last example that PT, the short side, is going to be half as long as the longer side of the whole thing. So if that's the case, 2 is equal to 1/2 of KP. How do we get rid of that multiplying by 1/2? Well, we divide by 1/2, which is the same as multiplying by 2. And so you find that KP is going to be 4 units in length. Now the follow-up question they could have asked is how long is KT going to be? Well, if this is 4 and this is 2, altogether KT would be 6 units in length. Here's your guided practice problem. It says if RP is 3.5 and JP is 9, find the length of each measure. And so you can look back right there. Now, finding the centroid on a coordinate plane. Here we have a word problem. It says a performance artist plans on balancing triangular pieces of metal during her next act. When one such triangle is placed on the coordinate plane, its vertices are located at 110, 50, and 95. What are the coordinates of the point where the artist should support the triangle so that it will balance? Now here's a hint. They say to understand. You're going to find the centroid of this triangle. That's where it's balanced. So the way I do that is I plot my points. 110 would be 1, 110 would be right there. Then the next point is 50 and then 95. So 50 and then 9. The last point. Okay? And so I connect my dots. Now, if I'm going to find this centroid, I want to find one of my medians. So the easiest one to find would be this one right here. The reason that is because it makes a nice horizontal line. And so I have then a centroid, or excuse me, a median with the length 1, 2, 3, 4, 5, 6 units in length. 6 units in length. And so to find that median then, I'm going to have to find it. I'm going to have to find that centroid is going to be at 2/3 of my unit, which would be 4 units away. So 4 units would be at this point right here, and that then would be the point 5, 5. So we go back to the question. It says, what are the coordinates of the point where the artist should support the triangle so it will balance? The point is 5, 5. Here's a guided practice problem. It said on the second triangle, here are the vertices. What are the coordinates of the point where the artist should support the triangle so it will be balanced, and explain your reasoning. So try this problem right now. That way we have a better understanding of where centroids are on a coordinate plane. The next thing we're going to talk about is what's called an altitude. Now an altitude we've kind of talked about before, either in geometry here or previously. And the altitude is the length from one of the vertices and making a 90-degree angle to the base. And you'll notice in the first triangle, this one right here, the altitude occurs within the triangle. But we also have times in this one when the altitude occurs outside. It's an exterior altitude of this. And sometimes if you have a right triangle, you'll see that the altitude itself is this side of the right triangle. Okay, so it can happen in, outside, or right on the triangle. Now, where all of the altitudes meet is called the orthocenter. Orthocenter. So right there would be the orthocenter point P. And the lines containing altitudes AF, CD, and BG intersecting at P is known as the orthocenter of ABC. That's my key concept right there. Alright, so it says find the orthocenter on a coordinate plane. So just like we did before, we're going to have to graph all the points, all the vertices of my triangle. So F is at the point -4, 2, or -2, 4. Okay, so that's F right there. Then we have G is at 4, 4. Okay, so that's G. And then the last point we have H is at 1, -2. So I'll kind of get rid of these extra points that I have in here that I drew. And I connect my dots. So that's my triangle right there. So my orthocenter is going to be located at the center of all of my altitudes. So the first altitude I can draw would be from H to FG. Okay? So it's going to be right there. And my next one I can draw is from F to HG. And the last one is going to be from G to FH. And you'll notice that they all meet at the same point right there in the middle. So that's going to be my orthocenter right there. And so the way I find that is I simply just find that point. So that's going to be the point 1, 2. So the orthocenter is located at the point 1, 2. Here's an example of another one where we can find the orthocenter found in triangle ABC. So, what we've talked about so far, perpendicular bisectors, those all meet at what's called the circumcenter. We have angle bisectors, where all those meet is called the incenter. We have medians, that's what we talked about today, where it hits at the midpoint of its opposite side, where all of them meet is called the centroid. And finally, the last one, an altitude, where it creates a 90-degree angle, is called the orthocenter. Where they all meet is called the orthocenter.